Hey everybody, we are going to do solving systems using elimination. This is the third way to solve systems of equations. And it's a pretty cool way too. I think that this one is a little easier even than the other, especially solving um, with substitution. But let's go ahead and try it with elimination. This is chapter 6. It is lesson 3. Solving systems by adding and subtracting. Use elimination. So in this case, I have 2x plus 5y equals 17, and I have 6x minus 5y equals 9. So notice that I have this term here, plus 5y minus 5y. Well, I can actually say that this means that this is 0. Oh, shoot. Hold on. Let me grab my pen so that actually writes. There we go. That makes that go away. So if that goes away, then all I'm left with is then what I'm left with are these other ones to add up. So I have 2x plus 6x, that equals 8x. I have 7 minus 9, that equals 8. And of course, I'll just divide by 8 on this side, divide by 8 on that side, and I'm left with x equals 1. So I'm going to write my answer way over here. 1. I still have to find my y. So I'm going to plop in my 1 into the equation and see what happens with the other one. Let's do it with this guy here. I'm going to plop in a 1, and I have 2 times 1 equals 2 plus 5y equals 17. I need to throw this 2 to the other side. I'm going to subtract a 2. I'm going to subtract that 2 here. That makes that go away. I'm going to subtract 2 over here. I'm going to rewrite this guy over here. 5y equals, and what is that? 17 minus 2. It looks like it's 15. So you may already see the answer. Divided by 5 on this side, divided by 5 on the other. That means that y is going to equal 3. My answer is 1, 3. Alrighty, there's another way to do it too. And this one is in multiplying. So in this case, I see that I have 2x plus 15y equals negative 32. 7x minus 5y equals 17. Notice the relationships between each of the x term, the y term, and the non-variable term. Because if you see an easy relationship, you may be able to just multiply. In this case, I see a clear relationship between 15 and 5. That 5 times 3 is 15. So if I were to multiply each of these terms by 3, I might be able to eliminate this. So I'm going to do that. Multiply everything by 3. Let's rewrite. 3 times 7 is 21x. Minus 15y equals 3 times 17. Hold on, my brain is not that good. 51. All right, now notice that what happens here is I've got a plus 15 and a minus 15. Sweet. When I add them up, we have 0. 21 minus 2 is 19x. And negative 32 plus 51, I'll need a calculator for that one. Negative 32 plus 51 equals 19. So I can already see it. If I divide by, I'll have to divide by 19 to get rid of this x here, and that makes x equals 1. I'm going to write my answer way over here. X equals 1. I'm going to plop that 1 into one of the equations. I'm just going to use the top one again because I've already written down here 1. So that leaves me with negative 2 and plus 15y equals negative 32. And I need to get rid of the negative 2, so I'm going to go ahead and do a positive 2 plus 2. To rewrite this, it becomes 15y equals negative 30. Whoa. And we divide by 15. Y equals negative, oh, you know what, 30 divided by 15 is 2, and I still have a negative, so it's negative 2. So y is going to be negative 2. If you plot, you may need to plop that into your calculator, but I can actually see it. I actually am dividing in hours in my head because 30 is the half hour and 15 is the quarter. So 30 divided by 15, and that equals negative 2. And final answer is 1, negative 2. Let's try another one. Alrighty. First off, I'm just going to search for relationships and see if I can see one. So first of all, I don't see any real clear relationships like in the last one where I could just multiply 1. It looks like in this case, I'm going to have to multiply both of the equations to come up with one. It's a little bit like trying to find a common denominator. But I'm noticing that if let's see. I need to zero out one of these guys. So, what if I were to multiply by, let me see what they did in the book. So what they did in the book is they multiply the top one by 3. Then they multiply the bottom one by 2. So I'm going to write the answer to this one over here and the answer to this one over here, so we have lots of space. 3 times 3 is 9x. 3 times 2y is 6y. I may have to write it up and down, not side by side. We'll see how this goes, okay? 3 times 3 is 3. It looks like it would be easiest to go ahead and put it over here because it's just going to end up being an adding problem. So 2 times 4 is 8x. Plus 2 times 3 is 6y. And 2 times 2 equals, 2 times negative 2 equals negative 4. Alrighty, so let's go ahead and figure this out. 9, oh, I see. So what they did in this case, they decided to subtract. So they have 9 minus 8x is 1x, so it's just x. x. What is 9 what is 6y minus 6y? 0 plus 0. And subtracting over here, 3 minus 4, that's negative 1. So, I mean, I can just pretend that doesn't even exist, and that leaves me with x equals negative 1. So when I take my x and I plop it into one of the equations, I should be able to solve pretty quick. I've got 3 plus 2y equals 1. Negative 3 right here. That's what I'm going to do to get rid of it. And if I do a negative 3 over here, I got to do a negative 3 over here. This equals negative 2. And then I'm going to divide by 2 here, so that I have negative 2 divided by 2. And negative 2 divided by 2 is actually negative 1 when I plop it into my calculator. So it means that my solution to my system, in this case, is negative 1, negative 1. Alrighty, that is it. The 3 ways to solve systems of equations. In this case, we used elimination. This is chapter 6. It is lesson 3. I want you to do some work on this and see if you can solidify it in your brain cells. Get after it.